Okay, question 3 on page 68, we have these graphs. We're told this is y equals f of x, and hopefully we can recognise that's an exponential function of some variety. So this is the equation y equals f of x, and we're told it goes through the point 0, 1. And we want to sketch the function now y equals 1 on f of x. Okay? So, let's talk first about the part over here. Alright? Firstly, it's going to pass through this point because we know when x is 0, y is 1. Okay? So the y value is 1. So that means the y value on our reciprocal function will be 1 divided by 1. The y value on our reciprocal function will also be 1. So it's passing through that point. Okay, that's the first thing. And then what's happening is as x approaches infinity, or as it gets larger, what's going to happen to this? We have 1 divided by something larger. It's going to get smaller and smaller and smaller. Okay? So as this function gets larger than 1, this function is going to approach 0. So we have an asymptote occurring here. Alright? Towards x. And in fact, as it approaches, infinity or 1,000 or whatever, we have 1 divided by 1,000, 1 divided by infinity. It's approaching 0, but it's still going to be positive. Okay, what about to the left of that? Okay, to the left of it, we have this number here is less than 1. Alright, so what we have is we have 1 divided by a number less than 1. Now I'll just point something out, like if you have 1 divided by 0.5, it's 2. If you have 1 divided by 0.25, 4. You have 1 divided by 0.125, 8. So what's happening as we get closer and closer to 0? This number is getting larger and larger and larger. And so as this function gets closer and closer to 0, okay, this value of f of x gets closer and closer to 0, we have 1 divided by a number approaching 0. This value gets larger and larger and larger, okay? So that means it's going like this, it's exponential in that direction, okay? And that's really the only features we need to demonstrate. We don't know any of the other control points, we just know that it passes through there, and that as this one gets large, this part's getting small because it's 1 divided by a large number. As this one gets small, this one gets large because it's 1 divided by a small number. Okay, the next one we have is a quadratic. So here it is here, and it passes through 0 and 3. And it has a minimum point of 1.5 and -2. Label our axes. Okay, now let's follow along from our notes books and let's use the properties of a reciprocal function. So that's in 3D on page 20 of our notes books. And let's apply this. The zeros of y equals f of x become vertical asymptotes on 1 on f of x. Okay, so this is y equals f of x. So that means for our 1 on f of x, now one thing we could do as well is we could find the equation of this quadratic, right? We're given the points, we can find that equation reasonably easily and just put it in our calculator. So you can use information like that. Nonetheless, let's do it straight from the graph. So we've said the zeros, that's the roots, they're going to become the asymptotes. So we need to indicate that. There's an asymptote at 0, and there's an asymptote at 3. Okay, those are the vertical asymptotes. We also have any vertical asymptotes on the function become zeros. Now, our quadratic does not have any vertical asymptotes, so we can ignore the second dot point. Let's move on to the third and fourth dot point. Local max, we don't have a local max, but we do have a local minimum. The local minimum becomes a local max. Now, this point here, all right, the x value of the local max is still going to be 1.5, but the y value is 1 divided by the y value of the function. So we have 1 divided by -2. So the y value of the local max then is 1 on top of minus 2, half. So that's going to be like here. Alright? So on our 1 on f of x function, we have a local max here. And we know the local max is there because, two reasons. It has the same x value. Alright, remember local minimum becomes a local maximum. That's the x value of the point. And then the y value is 1 divided by the y value of the function. The y value of the function is minus 2. 1 divided by minus 2 gives us that minus half. So I'll put that in there. The same x value, but the y value is the reciprocal of it. Okay, so that's the first part of our reciprocal function. And then we can just talk about what's happening at the extremes. We've got when f of x approaches 0, 1 on f of x approaches 0. Now we don't have the function approaching 0, but we do have it approaching positive infinity in both directions. So we can read the last dot point. When f of x approaches the last dot point and the one furthest to the right. When f of x approaches positive or negative infinity, 1 on f of x approaches 0. Alright? So here we can see the function is approaching positive infinity. That means as x is approaching infinity, this function is approaching infinity. So as x is approaching infinity, 1 on infinity is approaching 0. So what we have going on here is it's approaching 0 from the positive direction. I'll extend my axes out a bit to enunciate that clearly. And it's asymptotic here. And we have the same thing going on over this side. Okay? As x approaches negative infinity, as x is approaching negative infinity, y is approaching positive infinity. So we have 1 divided by positive infinity, it's still approaching 0 from the positive infinity. Okay, so that's how we get that graph. Does that look alright, Seth? Yep, Jack? Cool, alright. Then last one, we have a reciprocal function. And we can find the equation of this function as well. I'll just draw it like that. I'll draw it. So when we have an asymptote at x equals 4, and a horizontal at y equals 1. And it is here, and it is here. Okay, so we don't have a maximum or minimum point, so we won't need to worry about that. We do have a 0 though. Alright, so on our new function, the zeros of f of x become asymptotes. So we're going to have a vertical asymptote on 0. Alright, so that's our new function. So just to define clearly, in black I've got the y equals f of x, and in blue I've got y equals 1 on f of x. Good. Okay, so that's the first part. We have zeros become vertical asymptotes. So we've done that. Alright. Next, vertical asymptotes become zeros. Alright. Now we have a vertical asymptote at 4, don't we? So that means that's going to become a 0. Blue go. Oh, there it is. Okay, vertical asymptote at x equals 4, that's going to become a root. Very good. So it has to pass through that point. What other behaviour do we have happening? Local max, local min, we can ignore. Alright, when f of x approaches 0, 1 on f of x is approaching 0. Now we won't have that one. But what we have happening, alright, let's discuss what's happening here. As x approaches infinity, this function approaches 1. Alright, f of x approaches 1, which means 1 divided by f of x approaches 1 divided by 1. And so the reciprocal function is going to approach 1 as well. All right, so what's going on there is it's approaching 1. But it's approaching 1 from below because, and this is a little bit tricky, this is approaching 1 from above, and so it's always slightly positive, which means the denominator is always slightly larger. So 1 divided by 1.01, it's something just below 1 because the denominator is large. So that's what's going on here. All right, that's quite tricky. And if it's approaching 1, right, then we can anticipate this asymptote existing. Let's perform the other case first and then we'll confirm it. So we've got, that says f of x approaches, as x approaches positive infinity, and then we have the opposite occurring. As x approaches negative infinity, all right, this function is approaching 1 from below. All right, so this is just below 1. So we have 1 divided by 0.99999, okay? That value is positive. It's going to be positive, it's going to be just above 1. And then we know that it's that vertical asymptote at x is 0. Okay, so my blue function there, we've got a horizontal asymptote here. And we discovered that by talking about the behavior of the graph at the extremities as x approaches positive infinity, and as x approaches negative infinity. So tricky, okay, questions? What do you reckon? Good, Seth? Yeah, you happy with that one?
Yeah.
Yeah, cool, all right. Let's, yeah, Max?
It's unrelated.
Yeah, I'm going to move on. I just want to get through 3F1 because it is quite straightforward. We're just talking about the definition. So let's flip to 3F1. We'll do